look at, in preparation for the Super Bowl, you gotta understand the physics of kickoff, right?
Yes.
I mean, right? So let's look at the physics of a kickoff here. So player kicks football from ground level at an angle of 28.7 degrees with an initial speed of 35.0 meters per second. Okay, we want to know a couple things. We want to know the hang time of the football, how long is it in the air, how far does it travel, and what's the maximum height it gets to. Okay? All right, so what do you think? So what kind of problem does this sort of look like?
The kinematics problem.
Well, I mean, it is going to be some kinematics for sure. But before that, I guess this is a projectile motion problem, right?
Yep.
Okay, and so this really is just kinematics. I mean, we don't really have to do anything with forces. Once the football is in the air, what's the only force on it? Gravity, its own weight. And so really, we already know the acceleration, right? So we don't really need to do any dynamics force kind of stuff, right? This is just kinematics. But it's a little bit more complicated because it's kicked at an angle, right? So like we always do with projectile motion problems, what's our strategy here? How do we treat them? Say it again?
Yeah, break it up into problems.
Okay, we're going to break it up into components
Draw a picture.
and probably draw a picture. We're going to break it into components,
Write
into
down what you
horizontal
know.
and vertical components, right? Because we can separate the two, right? It's very convenient for us to do that because we know gravity acts only vertically. And so what do we know about the horizontal velocity if we ignore any air resistance? The Super Bowl, of course, is coated with slippery, so it's spare no expense.
Some kind of problem with that last year.
They were where the Tom Brady played.
Yeah.
Deflategate.
Oh, you didn't think he was serious?
I was about it.
She's just trying
About
to help.
it.
Okay, so what can you tell me about the horizontal component of velocity during a projectile motion problem? Constant, right? Velocity is constant horizontally, right? Vertically, it's going to change because gravity's acting. So let's break this up into horizontal and vertical components. So we got X and Y. Maybe we need a picture. So there's one thing that we probably do. Well, okay, we need a picture. So the football is kicked at a 35-degree angle, or excuse me, at a 28.7 degree angle with a speed of 35.0 meters per second. So if I draw the velocity vector, then it's just going to look like this, right? Whoops, my numbers mixed up. 35.0 is the magnitude, standard units, meters per second, and 28.7 degrees is the angle, right?
Yep.
Okay, so I'm going to need, if I'm going to add all the stuff that I know to these lists, what can you tell me vertically? What are some things you know vertically? What's the acceleration?
35. 9.8. Oh, sorry.
Okay, good. What else do you know? What's the initial vertical position?
0.
Okay, and we could even call that, couldn't we? We could even call that, why not call it, why not? Got that. Okay, because we know we have X's and Y's now. We don't need to call it D anymore. We call it X and Y to separate the two. So why not is 0. And we even know that what's the final position going to be? Okay, it is going to be 0. We kind of get a choice here, though, don't we? And we'll talk more about it. Let's hold off on that one for just a second. What else? We're missing something, though. What about horizontally?
You have an initial speed.
Okay, we know the initial position is 0 horizontally, and we have an initial, what's the initial speed?
35.
Okay, but 35 is mixed between horizontal and vertical, though, isn't it? Because
Yeah.
that's at an angle. So what do we probably need to do to that initial velocity vector?
Yeah.
Split it up, the X and Y.
That.
Split it into components. Sure. Let's break it up into an X component. So we'll call that V naught sub X, and a vertical component, V naught sub y, right? And we know what those are because it's a right triangle. And so what is V naught sub y gonna be?
Sine.
It's gonna be a sine issue, isn't
Yeah.
it? So it's gonna be the length of the vector times sine of the angle, because it's an opposite side, right?
Yep.
So 35.0 sine, let's just call it theta, so I don't have to write that number the whole time, okay? Okay, and the x component is just 35.0 cosine theta, right?
Yeah.
Okay, so those are numbers that we can add. And really, this is just, when I write down, it is initial velocity, but it's not gonna change for the x component, right? It's constant. So why not just write it as v sub x? V sub x is constant, and it is that. It is whatever, I'm just gonna write v naught to make it a little shorter. V naught cosine theta, and we know both of those things. V naught is 35, theta is 28.7 degrees, right? That's a number. We know that V naught sub y equals V naught sine theta, okay? And so that's a lot of stuff. Now we want to find hang time, okay? We want to find hang time, we want to find distance it travels, we want to find maximum height. How could we approach this problem? We did some stuff similar to this before. What do you think?
Right, well, I forgot, what is the actual, like, math for figuring out V naught Y and V naught X?
Because it's just, all we're doing is this. We're just saying if we have a right triangle, and this is V naught, and that's theta, then we know that if we're gonna solve, let's say we're gonna solve for this side right here, this is V naught sub y. Well, I know that the SOHCAHTOA relationship that relates the opposite and the hypotenuse
Sine.
would be sine, right? And so I'd get sine theta equals the ratio of V naught sub y over V naught, and I just solve for V naught sub y. But remember the trick, and you may not have been here the day I was reminded these guys of the trick. The trick is you always know that if you're breaking a vector into orthogonal components, the components are always going to be smaller than or equal to, right? I guess if they're maybe if the vector is already horizontal, one component is 0, right, and one component is just the vector. But the components of a vector can never be bigger than the vector, right? So we always know that we're going to either multiply by sine or cosine, which will always make the answer less than or equal to what you started with when you multiply by those, right? Does that make sense? So the question is just which one? I'm always going to multiply by sine or cosine to reduce the vector down to its components. All you have to do is answer the question, well, we know sine is an opposite issue, right? Opposite side of the triangle issue. And cosine of an angle involves the adjacent side. So you just got to ask, okay, well, that was a sine because it's opposite. So I know I'm multiplying by sine, right? Okay, so now what? So we got to think about our strategy here. Now, there's a couple ways to do this. We could treat the flight of the ball as starting when the football is kicked and stopping when it hits the ground. In which case, if we do that, we're going to choose the final velocity, or excuse me, the final position. So we might just call it y to equal 0. And we can do that. That's okay to do. But it's almost a little bit easier. Remember we did this trick with the kinematic stuff to say, okay, we know something additional. If we pick the apex of the flight, so when the ball gets to its highest point, what's true at the highest point of the vertical component of velocity? It's 0, isn't it, right? The highest point, if the ball's being kicked to you and you only see the vertical component, at the highest point, the ball's going to reach, it's going to stop and then start to come down, right? So if we choose instead, let's choose the highest point to be the end of the first half of the journey. Then we can do V, I'm gonna call this V 1/2 sub y, just to remind us that it's only halfway there, how about? Okay. What's that velocity gonna be, you just told me?
0.
Okay, good, so it's gonna be 0, that y component, right? And if we solve for that time then, because the time is really what we need, isn't it? We need to know, we're gonna need to be able to link the time that things are happening in the y column to the time that things are happening in the x column, right? Time is what's gonna stay the same, it's the same football after all, right? We're isolating the two components of motion, but as this is happening vertically, this is happening horizontally, right? So for example, if we wanna know the distance the football travels, we're gonna need to know over here the distance when the football hits the ground, right? In the vertical column, and then say, okay, well at that time, how far is the ball traveled horizontally, right? See what I'm getting at? So we're gonna call this T sub 1/2. So this is the halfway point, and that's what we're gonna solve for first up here. So what's the equation then? This acts like a final velocity and a final time, right? Because we're just breaking our trip up into the first half of the trip. At the end of the first half of the trip, these are gonna be the velocities and times respectively, okay? This is what we're solving for. What's the equation we would use? So we could use, we could use a pretty easy one here, couldn't we? We don't have to use the displacement ones or the position ones. We can just use the velocity one, right?
Yeah.
Yeah.
A equals.
Right, and that's one of the advantages of this. You see, if I had done this the other way, if I had said, okay, well, we're gonna go ahead and solve this for when y equals 0, okay, now I've gotta use the big daddy, right? And solving for t is gonna be a quadratic equation I've gotta solve, instead of being able to solve a simple little linear equation, right? So that's why this trick is just a little bit easier. Okay, so let's do this then. So we're gonna use the equation. Yeah. Use the equation, V equals V naught plus AT, and for us, these are gonna be y's, right? So we've got the halfway point, got that stuff, okay?
Yeah.
I wanna solve for t, so I'm just gonna subtract this away and divide by a, and I'm gonna get the time to the highest point is equal to the velocity at the top, which is 0. Let's just make that 0, right? So I'm gonna get minus V naught sub y divided by a sub y, right? Okay, and we can solve that. V naught sub y is just, yeah, that, isn't it, right? The V naught sub y, the initial component of velocity. So that's gonna give us 35.0 sine theta, which is just 28.7, negative, divided by negative 9.80. 1.715. Okay, so that's the time it takes to get to the highest point, right?
That's not hang time, right?
No, that's only the time. Hang time is going to be twice that, right? Because that's only the time it takes to get to the highest point. Now it's got to come back down, right? So we're sort of solving these out of order, probably.
Hang time's first.
Hang time was the first one. Okay, so I guess we could answer that one then. I got to get out of here. Okay, so what did we get? Negative 35 times sine 28.7
Yeah.
divided by negative 9.8 is that, is what you told me. So 1.71 blah, 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 that's the time. So So that's roughly equal to, whoops, 1.72, right? We'll keep it in our calculator though. So the hang time then is twice that. So 3.43, et cetera, et cetera. How many sig figs do we get to keep on this one? 3, so that's gonna be 3.43. And it looks like I need units, huh? So seconds. Okay, the football reaches a maximum height of what? Okay, well, maximum height. So now we need to know the height of the football at this time. So how could we do that? You gotta fill in another, right? Or we gotta use an equation maybe, right? Which equation are we gonna use? Take your pick.
Wait, we're trying to find.
Trying to find the height now, right? So we're solving
Yeah.
for,
Yeah, what are we trying
can I erase some of this stuff down here?
Yeah.
Okay.
This is, no.
So what we would probably call
Half this.
y sub 1/2, right?
Oh.
So that's gonna be the maximum height. So what equation could we use if now we know all this other stuff and we're trying to find y? We could use the third one, right? That'd be fine. We could use the Big Daddy and find height, because we've got the equation. So equation number 3 would be y equals y naught plus v naught sub y t plus 1/2 a sub y t squared, right?
Hey, but how are we gonna do T when we only have half?
You're right. So these, I need to put halves in here, don't I guess? So
Oh,
this
okay.
would be, that's a 1/2, and that's, oh, that's not a 1/2.
The half doesn't really matter though, because you could do it for any time, for all the y.
You're right. Yeah, you could. We're just saying the 1/2 just denotes that this isn't the very end, right? We're just kind of. Okay, so we could use that. What's another one we could use? I guess we could make the first one work, because we know the final velocity and the initial velocity, and the average would just be sum of the two divided by 2, so the right halfway between the two.
If you knew the distance, you could do the 2A delta D1.
We could, couldn't we? We could use the one without time also. Could also use number 4, because we know that the starting position is 0, and so the displacement is really just how high it goes, right? Does that make sense? So we could use this one. We could say v y 1/2 squared minus v naught sub y squared equals 2a sub y times delta y, right?
Let's do that one.
Yeah, which is just going to be y sub 1/2. That's probably the easiest one, isn't it? Okay, because this is 0. And so if we use this one, you can't read that probably. That's supposed to be, I'll just make that a delta y. So we're solving for delta y. So delta y then would just be negative v naught sub y squared divided by 2a sub y. So we can plug that stuff in. This is just negative, what was that again? That was 35 sine 28.7 squared divided by 2 times negative 9.8, right? Okay, so we get on top
You squared it.
oh, I don't think I squared it, did I? I gotta go back and do that. So I'm gonna go back. Oh, did I?
The answer is 14.42.
Yeah, so we gotta go.
Second delete.
So we gotta go second. And then I think I also forgot to put a negative out front. We would have figured that out. So yeah, 14.4. Okay. So the height, at the halfway point, the height is 14.4 meters, right?
Do we just, so that's the answer for the maximum height?
Yep, does that make sense? Okay, and then the last, so let's add that to our list here. So maximum height, 14.4 meters, and the football travels a distance of, well, how am I gonna do that one?
You need to do that on the X side.
Okay, we go to the X side, and what's our time gonna be? Now, this is actually the time it takes to get back to the ground. So it's gonna be, yeah, whatever twice that number right there is, right? So 2 times,
We did that one.
we did?
Mm-hmm.
Oh, it's right there, yeah, never mind. Yeah, we did. So 3.43, good, so that's our, and then that's an easy one, right? We have constant velocity, and so we get to use the first equation on this one. We know that x equals x naught plus vx times t. X naught is 0, so we get v cosine theta, v naught cosine theta times t, right? So we can do that. That's 35 times cosine times that. Gives us 105.3, but only taking it to 3 places. So this guy's got a heck of a leg. So that's 105 meters.
How did you know to go switch over to horizontal?
Because it wants to know the football travels a distance. Well, what's the missing word there? Horizontal distance, right?
Okay.
Because think about a kickoff. The guy kicks it off, and then it lands on the ground. And so how far vertically it's traveled a total displacement of 0. It's gone up and come down, right? But horizontally, it's how far is it going? That's the length of the kick when it hits the ground again, right? So there's an implied word there, horizontal. Okay, so let's check. Should we check our work? Just make sure.
Yeah.
Watch it all be wrong.
Oh, don't say that.
I always wonder that though, every time you do something. It just, they're all wrong. We're just like, oh, okay. Time to go home.
3.43 seconds, we said. 105 meters, we said. And 14.4 meters.
Why'd we go out of order? Yay.
Got it.
Okay.
How about
This
that?
probably doesn't- But it says it travels a distance before it hits the ground, but then you were like,
Right.
but didn't you say once it hits the ground?
Yeah, okay, so, but I have bad wording maybe. I just mean how far is it traveling as it hits the ground or something. Does that make
I was
sense?
just wondering.
Yeah.
It didn't make any difference.
Did you see what I'm getting at on that one?
Yeah.
Yeah.
We didn't get a check. Oh, yes, we did. Okay.
That's all that matters.
Got to get the check.
Oh, there it is.
All right.
I hate it when like the little boxes don't like
Yeah.
turn to the grid.
So-
Like keep checking it.
That's probably enough for a Friday,
Yeah,
huh?
right here.
Yeah.
All right, so
Confusing, it's probably the difference